Welcome to the debate. Imagine for a moment taking the beating mechanical heart out of a legendary 1990s Nissan Skyline R34.
The literal holy grail of JDM cars.
Exactly. The exact twin-turbocharged engine that gave this car the iconic nickname, Godzilla. Imagine ripping that out and just throwing it in the trash.
Sacrilege. Just right out of the gate.
Well, hold on, because in its place, you drop in a silent 800-volt solid-state battery system. Suddenly, the car is twice as fast, perfectly balanced, and objectively better in basically every measurable metric. But the question that immediately follows is it still Godzilla?
Right. Is it even the same car at that point?
Exactly. And today, we are looking at exactly that kind of controversy. We are examining the radical mathematical overhaul of a 1990s automotive icon, where builders have ripped out its legendary 2.6-liter RB26 engine to install a massive 150 kilowatt-hour solid-state energy system.
A massive, highly controversial system.
Right. So drawn directly from the engineering logs and our source material, we really have to ask, is this extreme conversion a pristine scientific breakthrough, or is it engineering sacrilege?
Yeah, it's a huge question.
For me, I'll put my cards on the table. This isn't just an EV swap. It's a definitive scientific breakthrough that objectively perfects a 1990s legend through superior mathematics, thermal efficiency, and precision weight distribution.
Okay, and I hear you on the math. The numbers are crazy. But to me, cramming physically incompatible 2026 high-voltage physics into a 30-year-old chassis is a dangerous defiance of physics.
Dangerous?
Yes, dangerous. It's a conversion that fundamentally strips this JDM performance icon of its raw soul and intended balance.
Well, to really get into this, I think we have to establish the baseline of what was actually achieved here. Because the unassailable empirical data and the source material, it paints a picture of a pure engineering triumph.
If you only look at spreadsheets, sure.
But let's look at them. The original RB26 engine delivered roughly 276 horsepower. By replacing that with a solid-state system that delivers a sustained 600 kilowatts, the builders haven't just bolted in a motor and called it a day. They have completely re-engineered the vehicle's physical footprint.
They gutted it, you mean?
They optimized it. They actually cut 200 pounds of drivetrain weight and achieved a perfect 50-50 weight distribution.
Wait.
And furthermore, just to finish the thought, they've achieved a 30% increase in energy density over a modern Tesla. That's alongside a 40% improvement in thermal efficiency over traditional lithium-ion setups. When you look at how they took a chassis we all revere and, elevated its capabilities far beyond what its original creators could have dreamed, it's hard not to see a masterpiece of modern engineering.
Look, the metrics you are citing are staggering. I will grant you that.
Thank you.
It's an incredible flex of modern technology, but my argument is rooted in the very warnings explicitly stated in the source text about defying the laws of physics.
I think defying is a bit theatrical, don't you?
Not when we are talking about a 1990s stamped steel unibody chassis. That framework was fundamentally not designed to handle the brute structural force of 600 sustained kilowatts.
But they reinforced.
Nor was it meant to house 150 kilowatt hours of solid-state modules that, as the text notes, literally shouldn't fit. Achieving these impossible power-to-weight ratios by gutting the legendary RB26 engine sacrifices the visceral tactile reality of Japanese performance. What we are left with is a sterile, numbers-driven science experiment, not a cohesive vehicle.
I see why you think that, but let me give you a different perspective. Let's dig right into that physical data, specifically the weight and the balance, because this is where the engineering really shines and directly addresses your structural concerns.
Okay, go ahead.
You talk about the chassis not being designed for this, but the conversion actually reduced the drivetrain weight by 200 pounds. Think about the world of horology, right?
Watchmaking?
Yeah, watchmaking. Like when people resto-mod a legendary vintage mechanical watch, they rebuild its internal movement using modern titanium and silicon. The watch looks identical on the outside, but inside it weighs less, it is perfectly balanced, and it keeps objectively better time.
Okay, but a car is not a watch.
It's a machine, though. How is making a car 200 pounds lighter ruining its balance? The builders achieved a perfect 50-50 weight distribution front to rear. From a pure physics standpoint, a lighter vehicle with perfect weight distribution is inherently going to experience less lateral load during cornering.
Right, statically.
They aren't stressing the chassis with more mass, they've relieved it of a 200-pound burden.
I'm sorry, but I just don't buy that. Let me tell you why. You are equating static weight distribution on a scale with dynamic balance in motion, and those are two wildly different engineering realities.
How so? Balance is balance.
No, it really isn't. Yes, they shaved 200 pounds overall, mostly by ditching the heavy iron engine block, the iron differentials, the massive exhaust system. And yes, if you park the R34 on 4 scales in a garage, it reads a perfect 50-50.
Which is the holy grail of sports car design.
But a car doesn't live on a scale. It lives in corners. The text explicitly states that skeptics called this solid-state energy density physically incompatible with a 1990s chassis. Why? Because of exactly how and where that mass has to be located.
Explain what you mean by that. If the mass is balanced, isn't it balanced?
No, because you have to look at the polar moment of inertia.
Okay, getting technical.
Think of a figure skater spinning on the ice. When their arms are pulled in tight to their chest, they spin easily and quickly. That was the original R34. It was a concentrated mass right over the front axle, with the mechanical drive shaft sending power to the rear.
Right, an inherently nose-heavy car, by the way?
But predictable. The chassis' rigidity, its spot welds, its suspension geometry, they were all engineered in 1999 around that specific concentrated mass. But when you take 150 kilowatt-hours of solid-state modules and distribute them into the floor pan, the trunk, every void where they quote-unquote shouldn't fit.
They fit beautifully, though.
But you are like the figure skaters stretching their arms all the way out. You've moved the mass to the extremities of the car. It takes far more force to rotate the car into a corner, and once it starts rotating, it takes far more force to stop it.
I mean, theoretically, yes.
Practically, yes. Cramming an 800-volt architecture into a 30-year-old framework fundamentally alters how the car handles torsional stress, regardless of what the static scales say.
But that assumes they are managing the power the exact same way a car from 1999 would, which they aren't. Moving to an 800-volt architecture isn't just about putting a bigger number on a spec sheet.
It's a massive number.
It is, but it changes the physical reality of how the car operates. By using 800 volts, they can use significantly thinner, lighter wiring. They can push massive amounts of electrical current to the motors with far less heat buildup.
Sure, the electrical engineering is sound.
And because of the precision of modern solid-state power delivery, they can manage traction and torque vectors at each individual wheel thousands of times a second. That is infinitely more accurate than a mechanical limited-slip differential from the late 90s.
Even the venerable Atessa system?
Especially the Atessa system. They are using software and instantaneous electric torque to actively counter the rotational forces you're talking about. The figure skater has jet thrusters on their hands now.
And that instantaneous torque is exactly the problem. You are applying 600 kilowatts of instant sustained electrical torque to a unibody frame that is decades old. You have to compare how the power is delivered.
It's delivered incredibly smoothly by the software.
No, an internal combustion engine, even a highly tuned twin turbo like the RB26, it delivers power on a curve. As the RPMs climb, the turbos spool up, and the torque builds progressively. It's a strong, steady push.
I think some people called turbo lag a flaw, actually.
It was character. An electric motor delivering 600 kilowatts is like taking a sledgehammer to the chassis. It is instant, violent force applied at 0 RPM. The metal fatigue on those old strut towers and suspension mounts is going to be catastrophic over time.
They can dial that back with the controller, you know.
But static balance and clever software do not protect you from dynamic structural twisting when you hit the chassis with a sledgehammer of torque.
I'm not convinced by that line of reasoning because you're vastly underestimating what this structural reality enables. Let's look at the sheer performance output.
Here come the spreadsheets again.
Well, they matter. The builders are targeting a 0 to 60 time of 2.4 seconds while simultaneously maintaining a 450 to 500 mile highway range. Do you realize how unprecedented that is?
It's impressive, yes.
They have effectively cured the range anxiety that historically kills standard EV conversions. Usually to make an EV classic car fast, you give it like a 100-mile range. To give it range, you make it sluggish and heavy.
True. The packaging has always been the bottleneck.
Exactly. By utilizing solid-state technology, they've made the R34 infinitely more usable, potent, and efficient than its petrol-powered ancestors.
That's a compelling argument. But have you considered what we actually mean when we call the Skyline R34 a performance icon?
It was the king of the street.
Right, and the source text itself poses the question, is this sacrilege? Ripping out the RB26 isn't just removing a heavy piece of cast iron. You are removing the literal beating heart of the vehicle.
Oh, so we're talking about feelings now, not engineering.
The enthusiast reality of the R34 is defined by its mechanical crescendo. It's the cast iron block, the individual throttle bodies, the very specific, intoxicating sound of the twin-turbo spooling up, and the tactile feedback of the GetTrack 6-speed manual gearbox.
It's nostalgia.
You had to actually drive it. Replacing all of that with a silent, sustained 600-kilowatt solid-state module completely guts the authentic identity of the car.
That's an interesting point, though I would frame it differently. I argue that the quote-unquote soul of Japanese performance has never actually been about a specific exhaust note or a specific inefficiency like turbo lag.
Inefficiency? Wow.
The soul of JDM engineering in the 1990s was the relentless pursuit of technological dominance. Let's look at the history here. The Skyline was known as Godzilla precisely because it used the most advanced computers available at the time.
For 1999, yes.
It had the ATTS ETS all-wheel drive system and super high-cast four-wheel steering. It was a supercomputer on wheels designed to destroy older, more traditional mechanical sports cars on the track.
But it was still mechanical at its core.
It was a technology showcase, so installing a 150 kilowatt-hour solid-state system with an 800-volt architecture is actually the most authentic thing you could do to this car. It perfectly honors the original philosophy of using cutting-edge tech to humiliate the competition.
I completely disagree with that definition of its soul. Yes, the R34 had advanced computers, but they were in service to a mechanical experience.
They were there to make the car go faster.
The computers managed the pistons, the valves, the fuel injection, all working in this violent, beautiful harmony. When you remove all the mechanical imperfections, like the turbo lag that forced you to perfectly time your downshifts, you aren't just upgrading the car, you are creating a ship of Theseus paradox.
The old philosophy thought experiment?
Exactly. If you replace every single thing that gave the car its character in the name of making it future-proof, you'll destroy the very thing that made it beloved in the first place. Yes, a 2.4-second 0 to 60 time is hypercar territory.
It's phenomenal.
It looks brilliant on a spreadsheet, but by erasing the mechanical heartbeat, it becomes a mathematical overhaul, completely devoid of the visceral experience. Perfection is often sterile, and in this case, it's boring.
Boring? A 600 kilowatt perfectly balanced R34 is anything but boring. You'd be pinned to your seat.
In silence.
But let's move past the philosophy and dive deeply into what makes this solid-state system a valid retrofit standard. Because this is where the real scientific breakthrough happens, and it directly addresses why they chose to do this.
Okay, let's hear it.
We need to talk about the 40% improvement in thermal efficiency over traditional lithium-ion builds, and how they actually achieved that.
I come at it from a different way, but I'm listening. Walk us through the thermal argument.
So, traditional lithium-ion cells use a liquid electrolyte to move ions back and forth. Under high-performance demands, that liquid gets incredibly hot, and if it gets too hot, it boils, leading to thermal runaway and battery fires.
Which is why early EVs on track days would just overheat and shut down after 2 laps.
Exactly. To prevent that, lithium-ion EV conversions require massive, heavy, liquid cooling systems. You're talking water pumps, radiators, heavy fluid flowing through the battery pack.
It adds hundreds of pounds.
Right. By moving to solid state, you replace that flammable liquid electrolyte with a solid conductive material, usually a ceramic or solid polymer. This fundamentally changes the thermodynamics.
Because there's no liquid to boil.
Exactly. It doesn't boil, it doesn't catch fire the same way. Because of that, you can throw away all that bulky cooling infrastructure. You can pack the cells incredibly close together. That is exactly how they achieve that 30% increase in energy density over a modern Tesla.
I'll admit the packaging density is impressive.
The text states clearly that traditional lithium-ion is too heavy and too weak for a performance icon like this. If we want to bring classic 1990s aesthetics into 2026 safely and effectively, solid state isn't just an option, it is the only valid mathematical standard.
The leap in solid-state thermal efficiency is incredible. I won't argue that. Eliminating the liquid electrolyte to stop dendrite formation and thermal runaway is a massive scientific milestone.
So you agree it's a breakthrough?
In a lab, yes, but look at how the source material describes the application of this technology in this specific car. It explicitly calls it a high-stakes technical challenge that involves cramming modules into spaces where they quote-unquote shouldn't fit.
Which they solved.
But they aren't doing this because the Skyline needed it. They are doing this to prove a point to the skeptics and to build the world's first long-range solid-state JDM monster. This reads entirely like an ego-driven race to solve range anxiety and grab headlines with hypercar numbers, rather than a respectful restoration of a classic vehicle.
I'm not convinced by that line of reasoning because innovation inherently requires pushing boundaries that skeptics say shouldn't be pushed.
Pushing boundaries is one thing, destroying a classic is another.
When the text says they are cramming modules where they shouldn't fit, that isn't an admission of sloppy engineering or an ego trip. It is an acknowledgement of the packaging revolution that solid state allows.
It's brute forcing a square peg into a round hole.
No, think about it. A traditional lithium-ion pack of 150 kilowatt-hours with all its necessary water cooling jackets physically could not fit into an R34's wheelbase without completely destroying the vehicle's floor pan and structural integrity.
You'd have to chop the chassis to pieces.
You'd literally have to cut the car in half. Solid State's 30% higher energy density allows them to distribute that massive energy capacity within the existing voids of the chassis. They didn't have to ruin the exterior lines. They are proving that 1990s aesthetics can handle 2026's most advanced power figures without breaking. That is the very definition of a successful proof of concept.
A proof of concept? At what cost to the vehicle's historical integrity over time? We go right back to the physics defiance of a 1990s chassis handling a sustained 600 kilowatts.
We covered this. The weight is down.
Let's put that power number in perspective. 600 kilowatts is equivalent to roughly 804 horsepower, sustained.
Which is awesome.
The text explicitly asked, can the R34 handle the future? The builders are betting that a 30-year-old metal fatigue profile can withstand nearly triple its original horsepower, delivered instantly without a progressive torque curve to cushion the drivetrain shock.
With advanced traction control, yes.
Even if the solid-state modules are smaller, denser, and run 40% more thermally efficient, you are still unleashing a violent, unnatural amount of physical force through an antique skeleton. You call it a proof of concept. I call it a high-voltage science fair project that uses a priceless, culturally significant JDM artifact as a disposable testbed.
It is hardly a disposable testbed if the result is a fully functional, superior vehicle with a 500-mile highway range that can outperform its petrol-powered ancestors in every measurable metric.
Superior on a track, maybe, but not in spirit.
We really need to look at the holistic achievement here. For the last decade, EV conversions of classic cars have been plagued by three main limitations: excessive weight, completely ruined balance, and terrible range anxiety.
True.
These builders looked at those three problems and systematically solved them using advanced energy physics. They didn't add weight, they cut 200 pounds. They didn't ruin the balance, they engineered a 50-50 static equilibrium. They didn't settle for a 100-mile range, they pushed it to 500 miles.
By throwing infinite money at solid-state batteries?
They aren't destroying the car, they are elevating it. By proving that dense, solid-state energy can retrofit into a notoriously complex 1990s chassis, they are providing a realistic roadmap for how we can save all classic cars from obsolescence in a zero-emissions future.
Save them by completely erasing what makes them classic in the first place? This is exactly the crux of the problem with worshiping raw metrics.
Metrics are reality.
Yes, a 30% density increase over a Tesla is a brilliant leap forward for the automotive industry at large. I agree that solid state is the future of mass market transportation, but applying it here in this specific manner to this specific car is what pushes it into sacrilege.
We're just going to have to disagree on what sacrilege means.
You say the original Skyline's soul was about technological dominance, but it was mechanical dominance. It was pistons, valves, individual throttle bodies, and gears working in violent harmony that demanded skill from the driver.
Driving an 800-horsepower EV demands skill, trust me.
The builders boast about breaking the limits of modern engineering, but in doing so, they've broken the historical continuity of the Skyline. By removing the turbo lag, the noise, and the vibration, they've removed the car's ability to communicate with the driver. It's a completely different car now, merely wearing an R34 costume.
Well, let's draw our arguments together as we are reaching the end of our analysis here.
Time flies.
It does. From my perspective, this solid-state conversion is an undeniable scientific breakthrough. The data from the source material speaks for itself. Replacing a 276-horsepower combustion engine with a sustained 600-kilowatt, 800-volt architecture, while actually reducing the overall drivetrain weight by 200 pounds, is a masterclass in modern packaging.
It's good packaging.
Utilizing solid-state technology to eliminate the flammable liquid electrolytes, achieving a 40% improvement in thermal efficiency and a 30% increase in energy density, it completely shatters the limitations of 1990s engineering. It proves that with precision mathematics and advanced materials, we can perfectly balance a classic chassis while propelling it into the future with a 2.4-second 0-60 time and a 500-mile range. It basically cures the fatal flaws of classic EV conversions.
And I maintain that while the raw metrics are undeniably a marvel of modern energy physics, the application here crosses the line into sacrilege. Gutting the legendary RB26 twin-turbo to cram 150 kilowatt-hours of high-voltage power into a 30-year-old stamped steel chassis is a dangerous defiance of physics.
Even with a 200-pound weight reduction.
Yes. The dynamic torsional stress of hitting an antique unibody with an instant sledgehammer of 600 kilowatts is reckless. The builders themselves admit they are forcing next-gen technology into spaces it shouldn't fit. They prioritize a physics-defying science experiment and spreadsheet hypercar numbers over the vehicle's authentic mechanical soul, leaving us with a ship of Theseus that looks like a Skyline but feels like an appliance.
Well, I think where we absolutely converge today, despite our differing views on the soul of the car, is on the sheer magnitude of the engineering feat presented in the source material.
Oh, undoubtedly.
Whether or not it truly belongs inside the engine bay of a legendary Nissan Skyline, the technological leap from traditional lithium-ion to a 150 kilowatt-hour solid-state module capable of delivering 500 miles of range is a monumental milestone in automotive physics. It completely redefines what is possible for energy storage, packaging, and thermal management.
I agree entirely on that front. The sheer density and thermal efficiency of the solid-state architecture they've utilized here is revolutionary. Moving away from the heavy, vulnerable, liquid-cooled limitations of traditional lithium-ion opens up packaging possibilities that were strictly science fiction even 5 years ago.
Exactly. Yeah.
The engineering leap itself is profound, even if I fundamentally disagree with the canvas they chose to paint it on.
It highlights a deep, ongoing tension between preserving our history and pioneering our future. The source material leaves us with plenty of room to explore how we define automotive heritage in an era of limitless voltage.
There's definitely a lot more to debate there.
Is the soul of a machine found in its original, vibrating, ticking mechanical components? Or is it found in its capacity to continually push the boundaries of what is technologically possible? That is a question we must all answer for ourselves.
A very tough question.
We'll leave you to ponder that vintage mechanical watch we talked about earlier. When every original internal gear is replaced by something objectively lighter, faster, and mathematically superior, does it still keep the same time?